Hello. Hi everyone. Myself Farko Jyotide. And in this video, we are going to solve a beautiful DP question that is from our latest contest, contest number 432, and it is maximum amount of money robot can earn. Although nowadays robots are earning more than humans, but uh, this is a medium level question. And uh, first of all, let's see how to build the intuition that it is a DP question. And how would you think of the solution? First of all, read the question at least. So you are given an in M cross N grid or matrix. A robot starts at the top left corner of the grid. Okay, the robot starts from the top left corner, grid 00, and wants to reach the bottom right corner. The robot can either move right or down at any point in time. Okay, so what we have understood by reading these lines, you will be given, let's take a very good brush. So you will be given a grid as said in the question, and let's not take a very big matrix. For easier understanding, let's take it small. Okay, so it has got n rows and m columns. Am I right? M rows and n columns. Yeah, it has got m rows and n columns. Now the robot starts from, this is a 0, this is 1, this is 2, this is column 0, column 1, column 2. Okay, so now the robot starts from the grid 0 comma 0. So the robot starts from this. Let's make the robot. Okay, and the robot will reach, the robot wants to go to this position. Okay, so this is the starting point. The starting point is 0 comma 0, and the ending point is n minus 1 comma m minus 1. And how can the robot move? How can the robot move? So can I select this stuff? How to select it? By the way, this is for pencil, color picker. No, this is for resize and sketch. Okay, this is selection, right? So I can take this thing, I can copy it. Okay, so now what I can do, see, I have got this. And what are the possibilities? What are the things the robot can do? The robot can, the robot have two possibilities. We have read till now. The robot can go right. Okay, let's take the brush. The robot can go right, or the robot can go down. The robot has only two options. He can go right by one position only. He is not like the brook of a chess. He is going like to the end. Rrr. That is not the case. So the robot can go right and the robot can go down. Now, what are they telling? Every grid contains a value, a coin in it, in each cell. The coin can be positive. If the coin is positive, the robot gains those many coins. And if the coin is negative, the robot encounters a robbery. Okay, a robber is also there in this question. And the robber steals the absolute value of the coin, I comma j. So what are they telling us? That, see, uh, each and every cell have a certain number of coins. Suppose this has 3 coins, this has 4 coins, and there can be negative coins as well. There can be negative 3. What does negative coin represent? negative coin represents that the robot encountered a robbery. Robbery? Robbery means negative coin represents that the robot and the absolute value of the negative one, that is, if it is -3, the absolute value is 3. So the thief will take away 3 coins from the robot that he have collected till now. I am referring the robot to he. That's just an assumption. Okay. So I am. The thief will take away the absolute value of those many coins from the robot. And this is the significance of a negative number. The next thing, and the robot has a special ability too. He can neutralize at most 2 cells, at most 2 robbery. Like suppose we have got, okay, suppose we have got v, yeah, suppose we have got, okay, so coming back to the problem, uh, the robot has 2 options, either to go to right or to go to down, and he can encounter a robbery whenever there is a negative number in a cell, and there is a superpower the robot has, and the superpower is he can at max uh, skip or dodge 2 robbery. Suppose here it is -3 and the robot goes in here, and he has 2 robbery options to dodge. He can dodge this means uh, the same number of coins that the robot has previously, he will have the same number of coins when he will uh, go from this cell, because the thief cannot take away or snatch 3 coins from him, because he is using his special power to neutralize the robbery. And suppose here is again -3, he again came here and he again neutralized it here, and here is again -3, then he cannot neutralize it here, because he has only at most 2 times he can neutralize the robbery. At the third time he can't neutralize the robbery, and he have to give the thief 3 coins. And this is like the question is trying to tell us. Another thing, the robot's total coins can be negative. The robot's total coins can be negative because suppose uh, take a condition that in each and every cell you have got, let's rub it right, brush Ctrl V. Okay, I need to, suppose in every cell there is some negative number, so while the robot will traverse from the starting point to the end position, then at last the robot will have some negative coins, right? Because he has 0 coins as starting, and at each cell he is giving away some coins to the thief, and at max he can dodge 2 times. So by giving away everything he can have, there is a possibility that he can have some negative fun. You have to return the maximum profit the robot can gain to the root. So you should able to like think that it is a DP question. Why it is a DP question? It is a DP question because here you can see V. Okay, here you can see that what are the options, and what are the options the robot can have. The first options to go right, the second option to go down, and after going right and after going down, there are again two options. What are the options? He can, if the cell contains negative number of coins, then there should be a robbery, but he can use his power or he can't use his power. There are again two options, right? He can use his power or he can not use his power. So what are the options do we get? Move right, move down. And if the coin is negative, see, if the coin is negative, he again have two options. What are the options? The options are, uh, he can use his power, he can also not use his power. So there are four possibilities we can see. There are two possibilities, but if the coin is negative, there are four possibilities. So what you can see, first of all, don't actually jump onto DP at first. First of all, try to solve it using recursion, then you can easily convert your recursive code into a memoization code, right, into memoization code. First of all, if I show you my wrong submission, then it will be much easier to get the thing. See, this is the function that is given to me. I have given a grid and each and every cell have some definite number of coins, and R represents the number of columns and C represents the number of rows. You can also take M and N, but M and N confuses me a little bit, so I took R and C. Here you can see I have used a 2D DP because at the first time I couldn't get that it is a 3D DP question. So I have used a 2D DP because if in this question the neutralization factor is not there, if this thing is not there that you can neutralize the robber, only you can move left and only you can move down, then it will be a normal 2D DP question. And I thought it like that way, so I haven't considered a 3D DP, and I have passed 0 comma 0. Why 0 comma 0? This is a recursive function f, and it will take the row index, the current row index, the current column index. Ci represent row index, Ri represent row index, Ci represent column index, Nn represent the number of superpower lifts or the number of neutralization power left by the robot. And what is A represents the coin array. I don't like to write every time coins every time. I don't like to type, so I have taken A, and it is a DP. Next thing, why I have considered a integer class here, why I haven't taken a single int. I haven't taken a single int, there is a reason, and I want to explain it to you. Taken this because, see, there is a thing that in DP what you used to do, you used to fill, suppose this is the DP array, you used to fill every cell with -1, right? Arrays.fill method or anything in C++, you are going to fill everything with -1. But here is a thing given that the robot total counts can be negative. So you can have negatives. You can have negative answers, and when you will calculate that if my dp is not equals to negative, then return it. If my dp is negative, then mm, again calculate the stuffs, then again do the recursive stuffs. This will be havoc, right? So suppose everything gets changed. This gets changed to 2, this gets changed to 3, but uh, this gives us answer as -1, this gives us answer as -1. So although it is giving me an answer as -1, but I am going to recompute it, because I will think that this -1 is not my answer, but this -1 is actually indicating that I haven't calculated that specific read, or that's for that specific column index and row index. So I want to check it as null, and in integer class only you can have that null thing. So I have used this integer class. And next time, what is the thing next? See, what is my base case? My base case is, you are starting from this position and you are going to the end, right? So my base case is when my row index is equals to r minus 1, number of row minus 1, and column index is equals to column minus 1. Again, there can be two things. If you have a superpower left, if you have the power to neutralize it, and your array, the element the cell contents is negative, then you can do two things. Then either you can dodge that thing to maximize, you can dodge that thing, or you can just simply return that what is there in that thing. So that is, I'm returning. Here should be three possibilities as such, that if it is greater than 0, I should return 0, and there should be three possibilities. See again, if dp of index, row index, and dp of column index is not equals to null, I'm able to use null because I have stored integer class variables here. So that's why I can use null here, and I'm returning dp of rici as int. Why as int? Because this will calculate it as int. Again, I am going to store move right and move down as minus infinity or integer dot mean value. Why I'm taking it as integer dot mean value? Because I'm going to calculate the maximum, and when you are going to calculate the maximum, then you should store the minimum, because if my column index exceeds, or if my row index exceeds somehow, then I cannot move right or move down, and in that case you should compare it. You should take the maximum one, right? And when you are taking the maximum one of move right and move down, so at that time you need to, I'm first of all assigning it as minus infinity, because I'm going to take the maximum one. And if it is negative and I have a superpower left, then I'm going to dodge. Dodge means 0. I'm not going to add those stuff, add the cell into it, and I'm going to calculate. I'm going to do the recursive call. What is the recursive call? The recursive call is row index, column index plus 1, because you're moving right, and one superpower have been lost, nl minus 1, the same array a and dp. And else, if you are not using the superpower, then you need to add that uh, that number of coins into what, and you need to call your recursive function again, that is column plus 1, because you are moving right. Next time you are checking for moving down, and by this way you are actually making the dp1. But here you need to see one thing. I haven't checked one condition. What is that one condition? That one condition is, I'm checking that if I have superpower left, and if my cell element is negative, then I'm simply using my superpower. No, that is not the right thing. Why that is not the right thing? That is not the right thing because see, see this stuff. Okay, I can see this stuff. Okay, okay, see this stuff. Suppose we have uh, thought that how many options do we have? We can move right, we can move down, and if it is negative, we can use our superpower, and we cannot use our superpower as well. But in this code, what am I going to do is, I am, as soon as encountering a uh, negative element in a cell, I am using my superpower. That is not the right thing. You should give two options to the robot, that you can use your superpower and you cannot use your superpower. And you, in those two options, what is maximum, you need to return that, right? So now if I will show you my code, it will be pretty clear. See what I have done. I have taken R and C as the number of rows and number of columns, and a 3DDP array. What is the 3DDP array doing here? The 3DDP array, why I am using a 3DDP array? Because here you can see three states are changing. You have to use that. How will you get to know that when to use a 2DDP array, when to use a 3DDP array, when to use a 1DDP array? You will get to know by uh, observing how many number of states are changing. Here you can see that row index is changing, column index is changing, and again the number of neutralizing powers left is also changing. So for this, the number of neutralization power changing, this is also changing. Because of this only we are using a 3D DP array. If it's not there, then we can simply use a 2D DP array using a right index, row index, and a column index. Next, R is the row number, C is the column number, and what is the base case? The base case is when it is negative and you have your superpower left. So you are at the last index. See this thing. Here you don't have to check the three conditions. You are at the last index, and if it is negative and you have some of your superpower left, then it is better to use that na, because you are at the last index. What will you do saving all those superpowers? You are at the last index, and if it is negative and you need to return the maximum, you need to return the maximum number of coins you've collected so far in this route. So best way, just use the superpower that. And while using that, if you are using that superpower, you are returning zero. You are not gonna rob yourself, and you are returning zero. And if either it is positive, or either you have no superpower left, it is still negative but you have no superpower left, then you don't have any option. You have to return what is present in that cell, right? Next thing next thing, as in a standard DP question, what we do, if DP of row index, column index, and the number of superpower left or the number of neutralization powers left is not equals to null, that means it has not been calculated previously. uh, Sorry, if not equals to null, that means it has been calculated previously, and as it has been calculated previously, simply return this thing. And next I am assigning mr move right and move down as minus infinity, because where we are returning the maximum one. And now we are checking the moving right condition. When we can move right, we can move right when there is a possibility to move right. suppose you are already here. From here you can't move right, you only have to move down, because if you move right, there is a array index out of bound condition will arise. So for checking that condition, I have uh, given this ci plus 1. If it is lesser than 0, then you can move right, and if it is negative and you have superpower left, here you have two things: either you can use the superpower or not use the superpower. But if you use it or not use it, you have to calculate both, and you need to return that thing which is like okay, yeah, you need to return that thing which is maximum. So I have used math dot max. 0 means you are using your superpower, you are preventing yourself from being robbed, and you are moving right. And as you have used your superpower, nl minus 1. And what is the next? You are not using a superpower, so nl is simply nl, and you are adding those things. So adding a negative number means you are giving it to the robber, right? So that's why I am adding it. Else, just add. If it is positive, just add and move to the right. The same thing is going to occur. The same thing we are going to code for uh, moving down. When we have to move down, suppose we are here, we don't have option to move down, then what we can do? So for that condition, I have checked ri plus 1 if lesser than r. Here we can either use the thing superpower or not use it, and like that you have calculated it, and you are returning it is equals to math dot max of move right or move down. What is maximum? You are returning it and again storing it in the dp. Can you see something that is we are calculating the same thing two times or not? See, here we are calculating ri ci plus 1 nl minus 1 a, ri ci plus 1 nl, no, ri ci plus 1 nl, yeah, yeah. See this stuff here. If I will show you, see, this is very very important. Ctrl C, and let's go to ms paint. Let's rub this whole thing. Text box here, Ctrl V. Okay, so see this thing here. You can see that you are calculating ri ci plus 1 nl here also, and you are calculating ri ci plus 1 nl here also. This is the three states that are changing, and you are calculating it twice. Oh my god, what am I doing here? I am calculating the same thing twice. So why am I calculating it twice? I can just calculate it once and reuse it. That is a better idea, na? I will calculate it and store it in a temporary variable or something like that, and I am going to reuse it for two times rather than just calculating, just traversing everything, going down the tree and calculating again and again. It is better. And here, the same mistake we are doing again in the moving down condition. See, if I will copy it, Ctrl C, and let's what is that text box, right? Ctrl V. Okay, okay. See, Ri plus let's take the brush. Okay, Ri plus 1 Ci NL, Ri plus 1 Ci NL. Oh no. So this thing we should store in a temporary variable, and we should reuse it. So can we reuse it? So let's copy the code and paste it in our this coding terminal. See, etc v. And let's take a temporary variable here. Okay, int temp here, just okay, ctrl c equals to ctrl v. Here just store it and use it temp and use it again here temp. Again here is this thing, right? Temp, going to use it here again, temp equals to. So it's no use of calculating it two times, right? We are a dump if we will calculate it, because it will take a lot of time. Temp, here it is a temp, should also be temp, and if I will run my code, it should work. Let's see, yeah, and if I will submit it, it works. Yeah, see, for this time it is taking 360 millisecond, and as soon as I have optimized it a little bit, it is taking 239 milliseconds. So these are the things you need to take into consideration. And if you want to see a pretty good code that has got great variable naming and stuff like that, you can just see this code. 1 2 ctrl v, just see this code. See, rows, columns are rows, this represents number of rows, number of columns. Okay, next thing, the time complexity and the space complexity. What will be the time and the space complexity? Let's drop this thing. Let's take the brush. Okay, here you can see one thing. In the after doing the memoization stuff in the deep equation, in the dp, so before doing the memoization stuff using only recursion, what will be the like time complexity? What can be the time complexity? The time complexity will be 4 to the power n cross m. Why 4 to the power m cross m? See, for every cell you have four options: either to go move right, move down, and if it is negative, you can use your superpower or you can't use your superpower. So there are four options. So in the worst case, we have to consider that everything is negative, and for that reason you have four options in each and every cell, and in each and every cell you are getting four options, that is 4 to the power n into m. That is the time complexity. And the space complexity is, what is going to be the space complexity? Suppose this is the matrix and you are going to traverse each and every cell, like this or like this or like this. Maximum the space complexity will be, what I can say, n plus m, I think, because you are going the row and you are going the column. If you move this way also, see, in x axis you are moving the whole row, and in y-axis you are moving the whole column. So for one time in recursion, you are going to stack up from the moving from the starting point to the end point. And like depth first search, you are going to the depth and you are coming back, going to the depth and you are coming back. So the space complexity is n plus m. And next, if you we will use memoization in this, what will be the time complexity? The time complexity, this is the exponential time complexity using recursion, and exponential time complexity are very bad and it will not get accepted anyways. So it will be big of memoization. Now we have done memoization. So mhm, what is the dp length? N into m. We have n into m into 3. We have m into 3 options. 3 because uh, see, there can be 0 superpowers, there can be 1 superpowers, there can be 2 superpowers as max. So there are 3 things. So n into m into 3 is my time complexity after using memoization, and the space complexity will be same, that is n into m. This is the implicit stack space in n plus m, and the memoization stack space will be n into m into 3. This will be the uh, space complexity. You can again use the tabularization method to reduce the space complexity significantly, but recently I am not quite comfortable with tabularization, and so up till this thing, bye bye, take care, thank you.